Chris took this cipher monitor that you have over there and in Richmond and just looked at what it was reading with no radiation sources around, and he got about 1.5 backgrounds, 1.5 counts per second. What are the sources of background radiation? You've got radioactive materials in the Earth's crust. Some of that radioactive material, well, most of it in fact, is thorium and uranium. And one of the decay products, don't worry too much what I mean by that, one of the decay products of thorium and uranium is radon gas. So that radon gas seeps up through the earth there and can be trapped inside a house. So they're two sources, direct exposure to radioactive material in the Earth's crust, breathing in radon gas that's in homes, and as I mentioned before, cosmic rays and things like that. This is a smoke alarm, and inside domestic smoke detectors you will have a 1 microcurie, 37 kilobecquerel source of americium-241, which is exactly what I've got here. It's a very small amount of radioactive material. You can in fact swallow that and pass it through the other end without receiving a significant radiation dose. I'll mention this first because this is a nuclear density moisture gauge. So that's used to measure things like density and moisture content of road construction materials. To measure density, see we've got a handle here and a source rod there. You'll punch a hole in the road construction material and push that source down into the hole. So you've got a radiation source here, and you've got a detector back up here in the body of the unit, and the thicker or the denser the intervening material, i.e. the material between here and there, the less radiation is going to get through, and that's how you measure density of road construction materials. Similar sort of principle is used with other fixed gauges that are used in all sorts of areas of industry. Here you've got a radioactive source in this source housing here, and you've got a detector below the pipe here, and that's measuring the density of stuff that's flowing through that pipe. A number of other areas of use. Medical radiotherapy uses high-intensity radiation to treat cancer. Cells that are rapidly multiplying are the cells that are most sensitive to radiation, and hence you use radiation to treat cancer. And cancer, as you may know, consists of a bunch of cells that are growing out of control very rapidly. So if you've got a human body here, you've got a cancer, say here, what you'll do is get a radiation beam, a nice collimated radiation beam, focusing down on that cancer, and then you rotate around the cancer so that the cancer is actually the axis of rotation, and that gets the biggest radiation dose, and the radiation dose to this healthy tissue outside is more spread out. Having said that, these days we don't have any radioactive sources in our teletherapy heads. They tend to be linear accelerators. Like X-ray units, you need power and a switch. And that can be said of all similar sorts of radiation. If you have an X-ray unit or anything like that, it is not radioactive. It doesn't emit radiation unless it's plugged in and you're initiating the exposure with a switch. This is industrial radiography. Industrial radiography uses high-intensity gamma sources, high-activity gamma sources, to basically take X-rays of things like welds and steel pipe. So you might have a weld and a steel pipe here. You have an industrial radiography pig, as it's sometimes called here, which contains the radioactive source in an S bend like this. So normally the radioactive source will be sitting in here. That goes out via sort of like a pigtail arrangement here to a wind-out device here. And it will exit here along another pipe and deliver its source there. So if you want to take an exposure, you will use this to wind the source out very quickly so that it sits there, and then you'll place a film on the other side here, and By that means you can take a radiograph of that well to see if there are any cracks or other defects in it. As I said, it uses a very high activity, very hazardous source of gamma radiation. And this is a dud, an empty example of an industrial radiography source. You've got the actual active bit above my fingers there. And this end here is attached to the rest of the cable. And that's what's wound out. I gave another dud to Chris so he can use it there. So here you've got the actual cable that goes to the wind-out device somewhere down here, which winds it out. There you've got the pig, which contains the source, and this is the cable. This is the tube going out to. I think that is probably what is being radiographed there. And being a nice, conscientious radiographer, he's got a radiation monitor to make sure that the radiation source goes out and comes back into the shielded container. There are two things I'll say about industrial radiography sources. This is the single highest radioactive source that you are likely to come across in your work. And you're probably just as likely to come across it as anyone else. So it's not just something that's the field of emergency response. Secondly, I'll show you what the dose rate is from these sources from a typical source like this at various distances later on. I think it's very soon. Thirdly, because of the arrangement of this connection here, some of the older units, this sort of wasn't very sturdy, and so what happened was that. And if the radiographer wasn't using a radiation monitor to ensure that the radiation source returned back to this shielded container, this radiographer wouldn't know that that thing's fallen off. Also, sometimes this thing can be bent and frayed and snap off due to the fact that it's going all around tubes and so forth. And in that case, it can be picked up by some unsuspecting, say, employee of the company or member of the public, put in their pockets, very close contact for a number of hours, and in that case, it can do some nasty damage. This source here is the single highest activity source that we have in Victoria. It is a very strong source of gamma radiation, and it's the Stereotech source down at Dandenong, the South Gippsland Highway, which I took Chris to see one time. That's used to sterilise, disposable medical products, beehives to kill the various infestations that they have there, mouse feed that's designed for, say, Walter and Eliza Hall, where they want to ensure that the mice are in sterile environments and they're having a sterile diet and so forth. That's currently sitting in a pool of about 6 metres of water because they often want to go inside the bunker, as I'll call it, to, say, do some maintenance or so forth. The bunker itself is a 2 metre thick concrete wall with an entrance maze and an exit maze. Product comes in, goes around the source, and then goes out. And when it's actually being used, that will be lifted out of the water and will be there ready to irradiate product. This thing here will deliver a fatal dose of 10 sieverts, which I think we'll mention later on, but a fatal dose at 1 metre in a matter of seconds. So it's a big and nasty source. So what do you see on manifests? What should you be scared of when you see numbers on manifests? If you start seeing gigabecquerels or terabecquerels, then you start treating it with a bit of respect. That's just a rule of thumb, I suppose.